Right now, something is happening 385 miles beneath your feet, and nobody on the evening news is talking about it. In the last 18 days, 6 major earthquakes have detonated, deep inside Earth's mantle, deeper than any fault line on any map. And today, a magnitude 7.1, the equivalent of 45 Hiroshima bombs, exploded 385 miles underground. No warning, no aftershocks. Just silence, which is somehow more terrifying. Here's what I'm going to show you in the next 17 minutes. And I promise this will change the way you look at the sky tonight. At 6 minutes, I'm going to reveal the connection between these earthquakes and what the sun did to us in the last 24 hours. At 10 minutes, the single most alarming data point I've seen in years. And at 12 minutes, a comet the size of Central Park is flying straight at the sun. And what happens on April 4th could affect every power grid in America. Let's go. First, let me introduce you to a geologist named Dr. Linda Sieber. She spent 30 years at Columbia University studying one specific question. Can an earthquake hundreds of miles deep trigger a catastrophic one at the surface? Her answer, published in the Journal of Geophysical Research, was yes. Not always, not predictably, but the mechanism is real. And right now, that mechanism is firing on all cylinders. So here's the deal with deep earthquakes, and this is the part nobody explains properly. Below 50 miles down, the rock shouldn't be able to snap. It's too hot, too pressurized. It bends like taffy, not breaks like glass. So when an earthquake goes off at 385 miles down, scientists genuinely have to ask, what the heck just happened down there? The answer is something called a mineral conversion implosion. Think of it like this: picture a can of soda being crushed. Deep inside the mantle, extreme pressure forces one mineral olivine to snap into a denser form called spinel. The volume shrinks instantaneously. The rock collapses inward, and in one single microsecond, you get an implosion the size of a small city, releasing 675,000 sticks of TNT worth of energy. Not a crack in the ground, not a fault slip, an implosion. That's why there are no aftershocks. There's nothing left to slip. The energy detonated in one catastrophic instant, and then nothing. The silence after a deep earthquake isn't reassuring, it's a red flag. Because it means the stress didn't fully release upward. It redistributed, loaded into the shallower fault systems above it. Like squeezing the bottom of a tube of toothpaste, the pressure has to go somewhere. Now here's the timeline that made my jaw drop. February 4th, magnitude 6.1, Kermadec Trench 104 miles deep. February 10th, magnitude 6.2, Fiji 317 miles deep. February 14th, magnitude 6.4, Vanuatu, shallow one, weird outlier. I'll come back to that. Today, a 6.0 near Fiji at 406 miles, then hours later. The 7.1 in Malaysia at 385 miles. 5 major earthquakes, 18 days, same region of the Pacific. The last time we saw a cluster like this in this exact zone, right before one of the most active seismic periods in the past decade. And here's something wild about where this is happening. Because the Tonga-Kermadec Trench system is genuinely unlike anywhere else on Earth. Most tectonic plates that sink into the mantle go down at an angle like a ramp. Not here. The Pacific plate here literally curls and goes straight down. Vertical subduction, like an elevator shaft into the Earth's interior. It's the only place on the planet where earthquakes can physically reach 430 plus miles deep. And we just had one at 385 miles right at the danger threshold. Now I need you to understand the scale of what 7.1 actually means. Because 7.1 sounds like a number on a weather forecast. It's not. The Richter scale is logarithmic, meaning each whole number is 31 times more powerful than the last. 7.1 releases more energy than every conventional weapon. Fired in World War II combined, that energy detonated 385 miles underground. Because it was so deep, the surface barely shook, no tsunami warning. But that's actually the scary part. The energy didn't dissipate. It went somewhere. Before we get to the sun connection at minute 6, I want to give you one more context piece. That makes this cluster genuinely alarming. From December 8th, 2025 to today, there were 0 magnitude 7 plus earthquakes worldwide. 0. For 77 days straight. Geologists call it a seismic drought. And here's what historical data shows happens after a drought this long. You don't get just one earthquake to break the silence. You get a burst, multiple 7 plus events, different fault systems, weeks apart. The Earth isn't random, it's a pressure system. And when it goes quiet for 77 days, it's not resting, it's loading. We may be at day 2 of a seismic burst right now. Don't miss what's coming up, because at minute 6 I'm connecting this to something happening in space that most people have zero idea about. And once you see this connection, you won't be able to unsee it. All right, minute 6, I promised you this, here it is. There's a researcher named Dr. Arkady Spivak, Institute of Earthquake Prediction Theory, Moscow. He spent 15 years doing something that most Western geologists considered fringe, mapping the statistical relationship between solar activity and earthquake frequency. His data set 40 years of seismic records against 40 years of solar wind data. His finding replicated independently by a team at the University of Athens in 2019, within 1 to 3 days of a specific solar event hitting Earth's magnetic field. Large earthquake frequency jumps by a statistically significant margin. The solar event, something called a coronal hole high-speed stream. A coronal hole is literally a hole in the sun's outer atmosphere, a region where the sun's magnetic field opens up and shoots a river of charged particles directly into space at 1.5 million miles per hour. When that stream hits Earth, it compresses our magnetic field on the day side and stretches it on the night side. The planet literally gets squeezed. And that electromagnetic squeeze, according to the research, may be enough to nudge fault systems that are already loaded and ready to go. It doesn't create earthquakes from nothing. Think of it like a trigger, not a cause. The gun was already loaded by tectonic stress. The solar stream pulls the trigger. And here's the part that stopped me cold when I pulled up today's solar data. We currently have one of the largest coronal holes of the year facing directly at Earth. Its high-speed stream hit our magnetic field in the last 24 hours. A geomagnetic storm is active right now as we're having this conversation. And within hours of that impact, a 7.1. The timing is exact. Now I want to be straight with you. Correlation isn't causation. Science isn't fully settled on this. But here's what is settled. 50 years of data shows earthquake activity historically increases after solar maximum ends, not during it. The counterintuitive reason during solar max, Earth absorbs enormous electromagnetic energy, stores it in the crust and mantle, then as the sun quiets, Earth exhales. Through earthquakes, through volcanoes, we are at the beginning of that exhale right now. Okay, here's your practical action step right now before we go any further. If you live on a fault line, California, Pacific Northwest, Alaska, Hawaii, this week, not next month, check your emergency kit. 72 hours of water, 1 gallon per person per day. Non-perishable food, flashlight, medication. Know your building's earthquake rating. Know your evacuation route. And bookmark spaceweather.gov NOAA's free real-time space weather tracker. Sign up for their free email alerts when a G3 or higher geomagnetic storm is forecast. Consider unplugging major electronics overnight. Power surges from these storms are real. And they fry equipment that isn't protected by a quality surge protector. All right, that's the ground situation. Now let's look up, because here's the data point I mentioned at the top. The single most alarming thing I've seen in years. 2025 was the 7th most seismically active year in recorded history. 7th out of every year since humans started keeping records. The 6 years above it on that list, every single one had either a magnitude 9+ earthquake or a catastrophic global geological event. 2025 had neither, and it was still 7th most active. That's not a statistical blip, that's a signal. And now we're entering what the data suggests will be an even more active period. But wait, there's a twist, because something else is coming. Something that has nothing to do with fault lines and everything to do with what's above our heads. Something that could turn April 4th into either the most beautiful night of your life or the most consequential space weather event in modern American history. I want you to picture Mark Thompson, an amateur astronomer in Namibia, Africa. February 18th, 2026, 2 a.m. local time, he's out in the desert with his telescope, doing what he does every clear night, scanning the southern sky for new objects. And there it is, a faint smudge of light no one had documented before. He stares at it for a full minute, then picks up his phone and calls his colleague. Mike, wake up, I think we've got something. That smudge has a name now, C/2026A1. Scientists are calling it MACE. And if the current trajectory holds, it will be visible to the naked eye from your backyard on the evening of April 4th. Here's the backstory on what this thing actually is, because it's genuinely wild. Thousands of years ago, astronomers estimate around 900 AD, A massive comet flew too close to the sun. The sun's tidal forces ripped it apart. It shattered into hundreds of fragments, all still orbiting the sun on roughly the same path. Scientists call them the Kreutz family, named after the astronomer who first mapped them. Mace is one of those fragments, a piece of something that once grazed the sun over 1,000 years ago and is now coming back to finish the journey. Here's what makes Mace different from every other Kreutz fragment we've tracked. It was detected farther from the sun than any Kreutz sungrazer ever recorded, beyond Earth's orbit, and we could already see it. That means one thing and one thing only. This comet is large. Estimated diameter up to 1.5 miles across. That's roughly from Times Square to Central Park. For a comet nucleus that's substantial, most Kreutz sungrazers are city block sized. The ones that made history, the Great Comet of 1882, Ikeya-Seki in 1965, were large enough to survive perihelion. The small ones just evaporate. The sun basically vaporizes them before they can even put on a show. But Mace has the mass to potentially hold itself together. And if it does, here's what you could be looking at. The Great Comet of 1882 reached apparent magnitude -3. Bright enough to cast shadows at night, visible in broad daylight. Ikeya-Seki in 1965 was so bright people reported seeing it in the middle of the afternoon, just by shielding their eyes from the sun. Mace's current light curve, the rate at which it's brightening as it approaches, is tracking above average for its class of sungrazer. If that trend holds, scientists calculate it could rival Venus in brightness. A comet blazing next to the sun, visible at dusk and dawn from your driveway. No telescope needed, just your eyes and a clear sky. But, and this is the plot twist, there's a second scenario. One where Mace doesn't survive perihelion, one where it hits the sun directly. And when a comet hits the sun, something violent happens. Let me tell you about June 15, 1859, a telegraph operator in Pittsburgh, Pennsylvania. A guy named Elias Loomis was sitting at his desk at 8 in the morning when his telegraph machine started sparking and smoking. Without anyone sending a signal, the wires caught fire. Across the country, telegraph offices burned. Northern lights were seen as far south as Cuba people thought cities were on fire. Compasses spun randomly. The entire electrical infrastructure of the era destroyed in a single night. This was the Carrington event, caused by a coronal mass ejection slamming directly into Earth's magnetic field. Now in 1859, the most advanced technology was a telegraph wire. Today, your GPS, your phone, your bank's data network, every hospital, every power grid in America, all of it runs through electronics. That did not exist in 1859. A Carrington-level event today would take down the eastern seaboard grid for an estimated 4 to 10 years. That's not a movie plot. That's a FEMA risk assessment from 2017. Now, does Mace hitting the sun guarantee a Carrington-level event? No, absolutely not. Comets hit the sun more often than you'd think. And most of them don't produce significant CMEs. But Mace is not most comets. At 1.5 miles wide, it is roughly 10 times the estimated size of Comet Lovejoy in 2011, which did trigger a significant CME on impact. The larger the comet, the larger the potential disruption. Here's what we actually know versus what we're guessing, and I want to be straight with you on this. We will not have a confident prediction until late March. That's when we'll have enough brightness data to determine whether Mace survives, or whether it's heading for a direct impact. Right now, it's genuinely a coin flip. What we do know, current brightness tracking above average for its class. Nucleus size suggests survival is more likely than for typical Kreutz sungrazers. Perihelion is April 4th, roughly 3 a.m. Eastern Time. Impact or closest approach, same date. So here is your practical guide step by step for watching this yourself. Right now through March, the comet is only visible from the southern hemisphere. Late March, look low in the western sky after sunset from anywhere in the U.S. Download Sky Safari or Stellarium, both free apps, and set an alert for April 3rd. Around April 3rd through 5th, if Mace survives and brightens as predicted, you'll see a bright smear of light near the horizon at dusk and dawn. Do not look directly at the sun to find it. Use those apps to get the exact position. It'll appear several degrees away from the sun near Venus on the western horizon. If it becomes as bright as predicted, you won't need a telescope. You'll be able to see it standing in your backyard. Now let's step back and look at everything we've covered together. In the last 18 days, 6 deep earthquakes in the Pacific. A 77-day seismic drought just ended, historically followed by seismic bursts. The Sun is entering its descending phase with a large sunspot group rotating toward Earth, and a coronal hole high-speed stream already hitting our magnetic field. A comet 1.5 miles wide is on a collision course with the Sun, with two possible outcomes: the sky show of a generation or a space weather emergency. And on March 3rd, a total lunar eclipse visible from the west coast, Hawaii, and across the Pacific right in the middle of all of this. Here's the thing I want you to leave with, and I mean this genuinely. None of this is reason to panic. All of this is reason to pay attention. Human civilization has survived every solar storm, every seismic burst, every close approach comet in recorded history every single time. The difference between the people who were okay and the people who weren't wasn't luck, it was preparation. And right now you have time to prepare. That's actually the good news here. Now here's what's coming in the next video. Underneath the South Atlantic Ocean between South America and Africa, Earth's magnetic field has a hole in it, a growing hole. Scientists call it the South Atlantic Anomaly, and the latest data shows it's splitting in two. Here's why that matters to you personally right now. Today, every satellite that carries your GPS signal, your phone's data, your bank transactions, passes through this anomaly multiple times per day, and satellites are already malfunctioning when they fly through it. NASA has documented the failures. The anomaly is getting bigger every year. What happens to your GPS, your phone, your access to your own money? When that anomaly fully splits, that's the next video. Hit subscribe so you actually see it when it drops. The algorithm won't show it to you otherwise. And if this changed how you see what's happening to our planet right now, share it with someone you care about, because the most dangerous thing right now isn't what's underground. It's not knowing it's there.